Hello everyone, and welcome to this tutorial on the Rust programming language. My name is Metahan, and today we will be delving deep into Rust. So, what is Rust? Rust is a memory-safe compiled programming language that delivers high-level simplicity with low-level performance. So, why should you choose Rust? Rust is a popular choice for building systems where performance is absolutely critical, like game engines, databases, or operating systems. It's also an excellent choice when targeting WebAssembly. It offers the safety and the ease of use of high-level languages with the performance and control of low-level languages. Now, let's do a brief history of Rust. Rust started as a side project of Graydon Hoare in 2007, who named it after the Rust fungus. It was sponsored by Mozilla in 2009 and has been ranked the most loved programming language every year since 2016 by the Stack Overflow Developer Survey. Fans of Rust are affectionately known as Rusticians. And yes, this programming language actually has fans. What separates Rust from other languages? Traditionally, high-level languages use a garbage collector to manage memory, while lower-level languages provide direct memory management functions. Rust takes a different approach, achieving memory safety with a concept known as ownership and borrowing. By default, every variable in Rust is immutable. This allows values to be stored in stack memory, which has minimal performance overhead. Mutable values or objects with an unknown size at compile time are stored in heap memory. Every value in Rust program is assigned to a single variable known as its owner. When that variable goes out of scope, the memory allocated to it is dropped automatically. One other feature that separates Rust from other programming languages is ownership and borrowing. In some cases, you might want to pass a reference to a different part of the program. This is where borrowing comes into play. Borrowing allows you to access a reference in memory without taking ownership of it. Rust's borrow checker validates the rules of this system at compile time, keeping your code safe while providing absolute control over performance. Let's check out another feature. It's Cargo, Rust's package manager. Rust also has a package manager called Cargo. Each individual package is a crate. To get started with Rust, install it, then run cargo new from the command line. In the main.rs file, you will find a main function, which is where the program starts executing. Now, let's start with some examples with Hello World. Here you see the main function with println macro that writes Hello World. Now, let's do a simple Rust program. Declare a variable with let, followed by its name and type. The value can't be changed or reassigned by default, so add mute to make it mutable. The name of the variable is the owner. A reference to its location in memory can be borrowed by other parts of the program by prefixing it with an ampersand. Then use a macro like println to log the value to the standard output. Rust also comes with a standard library that contains modules to handle I/O, the file system, concurrency, amongst many other things. Now, let's do more examples of Rust's distinguishing features. In languages like Java or Python, memory is managed through a garbage collector. This can lead to performance issues because it's not always clear when the garbage collector will run. In contrast, Rust uses a system of ownership with a set of rules that the compiler checks at compile time. Once a variable's scope is over, Rust automatically frees the memory. This eliminates a whole class of bugs and security vulnerabilities related to memory management, without the overhead of garbage collection. Now, in this code we are trying to print S after its ownership has been transferred to takeOwnership function. This results in a compile time error, preventing us from using memory that's no longer valid. Concurrency is notoriously difficult to get right. One common issue in concurrent programming is the data race, where two or more threads access the same memory location concurrently and at least one of the accesses is a write. Rust's ownership and type system helps prevent data races at compile time. You can't accidentally share mutable state across threads. If you try, you'll get a compile time error. In this example, we are trying to mutate other data from a new thread while also mutating data in the main thread. This would cause a data race in many languages, but in Rust, it is a compile time error. One of Rust's goals is to provide zero-cost abstractions. This means you can use high-level abstractions, but they compile down to code as efficient as if you had written low-level code yourself. In this example, the enumerate function is a high-level abstraction that adds indices to an iterator. This compiles down to a loop that's efficient as if you had written it in a low-level language. Null values can be the source of many bugs in programming languages. Rust does not have null values. Instead, it has an option type to represent values that might be absent. This forces you to write code that explicitly handles the case when a value might be missing. In this example, absent number is of type option and is set to none, meaning it doesn't hold any value. Trying to directly print absent number would result in a compile time error. To use this value, we need to explicitly handle the case when it might be none. This ensures that null reference errors, which are common in many other languages, cannot occur. Here is how we should handle an option in Rust. In this corrected example, we use a match statement to handle both the sum and none variants of the option. This way, Rust forces us to acknowledge the possibility of none before we can use the value, thereby avoiding null-related bugs. These features, memory safety without garbage collection, prevention of data races, zero-cost abstractions, and the absence of null values are some of the key aspects that set Rust apart from other programming languages, making it a strong choice for reliable, efficient, and safe software development. In Rust, the Rust compiler is used to compile your code into an executable. This executable can then be run from the command line. For example, if you have a Rust file named main.rs, open your terminal or command prompt. Navigate to the directory containing main.rs file. Run rustc main.rs to compile your code. This will produce an executable named main or main.exe. Now, if you are on Unix-based system, you will write this to open your executable. However, I am in Windows, so I will do this. Now this executes our program. This process gives you a memory-safe executable that can handle the most performance-intensive system requirements. Rust is a powerful language that gives you control over the performance of your system, while also providing memory safety and concurrency handling. It accomplishes this through its system of ownership and borrowing and by enforcing strict compile time checks. It is worth noting though, that while Rust has a steeper learning curve compared to other languages, its design choices are made with the intention of preventing bugs and ensuring runtime efficiency. The Rust community is vibrant and growing, and there are many resources available for learning more about Rust. In the world of programming, those who use Rust are often known as Rusticians. The Rustician community is known for being particularly friendly and helpful, so don't hesitate to reach out to others as you continue your Rust journey. Remember to like, subscribe and leave comments if you want to see more content like this. Your feedback helps in creating better and more targeted content. Lastly, don't forget that becoming proficient in any programming language takes time and practice. Keep coding, keep exploring, and most importantly, have fun while you are at it. Happy coding, everyone!